Concerts. We've all been to one. I hope. If you've lived, you've been to one. But have you ever thought about how they work? Especially in today's age, how does it work that you can buy tickets somewhere, a different platform, a different website, and access the concert at a different location, different platform, different website? Does that make sense? Let's think about it for a second. You want to go to a concert, one of your favorite music artists out there. You're pumped, you're eager. Where do you go? Eventbrite, Ticketmaster, wherever this app is on your phone, you go there and you buy this ticket on Ticketmaster or Eventbrite or wherever else is out there. And then you go to the concert at the XYZ stadium, you show the ticket from a third party. It's Ticketmaster. And XYZ is supposed to just believe third party, believe that, the third party verified that you are who you say you are and you actually spent money to buy this ticket. And then once it believes that the third party believes that, you are who you say you are, just automatically believes you because the third party believes you. Is that how it's supposed to work? Yeah. In fact, we just described OAuth. OAuth, the open authorization standard that allows authorization and authentication to services utilizing a third party type of verifier. If a third party can verify who you are, you don't need to give your credentials or have to log in to the resource where what it is you want to access sits behind. That's OAuth. And in this video, we're going to go over an overview and we're going to lift under the hood and really understand what OAuth is at a fundamental level. My name is Pat, and buckle your seatbelt. It's going to be a fun one. So what is this OAuth that we speak of? Where does it come from? Why does it even exist? Where was it made? Sit back. Let me tell you a story. So, where it all started, 2006. Around that time, users would have to log in individually to each application. This means that every developer for every single application was responsible for their own authentication. They'd have to set it up, they'd have to configure it, they'd have to store user credentials, username, password, the whole 9 yards, the whole process. Now, there were big businesses looking to delegate this authentication, basically saying they don't want to have to set it up, they don't want to have to manage it, they want to delegate it to another service. How that would look is an API, as you know, handles the authentication. Instead of connecting to the backend of that application, the API would just receive some kind of token or verification from a third party. That's pretty much it at an overview. But this proved to be challenging. You see, it started with Twitter. Well, it started with Blaine Cook, someone who was working at Twitter, and they wanted to delegate the access piece for the Twitter API. And there were some standards that might have worked, but they weren't open standard. You see, Cook was working on something called OpenID. Now, OpenID existed. He was just working on implementing that for Twitter's API. OpenID handles identification, but not authorization. So he had to find something that was open standard, work with his own implementation of OpenID, and fulfilled the authorization piece. So what happened? Blaine Cook didn't find anything. In fact, he ended up having to work with the Google team, small users on the Google team, and the overall community to create what is known as one of the first open standard OAuth protocols. Now, let's back up a little bit. What is open standard? What does that even mean? And why didn't they exist? Well, open standard simply just means that it is a standard that is freely available to all users for updates, implementations, and changes. That's all. So Blaine did his research. Blaine looked at a lot of different protocols. There was Google's AuthSub. There was AOL's OpenAuth. There was Yahoo's BBAuth. There was the API, Flickr API, I think you call it. The point is, there was a lot. There's a lot of standards out there. However, Blaine discovered that none of them were open standard. Thus, he set out with his Google team and people from Twitter and the greater community to create in 2007, October 2007, what was known to be the OAuth Core 1.0. It was a document that pretty much outlined the first standard of OAuth 1.0 Core. What did this document talk about? Well, in simple terms, it pretty much allowed a website or an application to access a protected resource without the user having to share his own password. It was a passwordless protocol. Just like when you pull out your phone and you log into Ticketmaster, buy a ticket in order to go to that concert at XYZ Stadium. Yep, Ticketmaster. They use OAuth with OpenID. The same OAuth that Blaine Cook sought to create and the same OpenID he sought to implement. It's the same thing. And it's really easy once you start looking at what OAuth is under the hood and how it works. Let's dive in. Okay, so we're going to dive into the inner workings of OAuth, and I'm going to crack it open so that you can better understand how OAuth works. And hopefully by the end of this demo here, you have a basic understanding of just the process behind OAuth, how web browser can speak to a third-party service that will then reach out to another third-party service to verify who you are and grant you authorization to a resource that you're trying to obtain access to. Sounds like a lot. We'll go through it. It'll make sense. Before I go through it, I do want to mention OAuth has something called modes. Modes are just different kinds of implementations for OAuth. There are currently about 8 modes that OAuth offers. We're only going to go through one that I think you have seen more often, but just know that there are modes like there's local login and registration, right? There's third-party login and registration, which is called federated identity, which is kind of the scenario that we're going to be covering. There's first-party login and registration. There's enterprise login and registration. And even with the enterprise login and registration, you can delegate the authorization server to a local authorization server within an enterprise. So that's usually used with something called a SCIM, SCIM, which is pretty much like a service that allows you to use your own enterprise server instead of a third-party application. We're not going to cover that. We're just going to cover the third-party login and registration. And then there's third-party service authorization. There's first-party service authorization. There's machine-to-machine authentication and authorization. And there's device login and registration. So those are the 8 modes of OAuth. As I said, we're going to cover third-party login and registration pretty much. So the flow of this is we're going to have our browser, right? So we have our browser here, which will be talking to a web server. In this case, it's going to be an application, right? And we want to ultimately access a resource that sits behind the resource server. And we're going to see how the application will talk to the authorization server in order to allow us to access the resource behind the resource server. First step, for simplicity, the scenario that we're going to be talking about is, let's say you are at Walmart and you want to access photos that are on your Google Photos service, or the application, the Google Photos application. In this case, you open a photo app from Walmart and you need to be able to access your photos that are stored in Google's local storage. Disclaimer, I am not sponsored by Walmart or Google. If they'd like to sponsor me, feel free, but this is free revenue for them right now, free advertisement. So first step in OAuth to initiate the OAuth process and OAuth flow is a request. So first is when you initiate the request that begins the OAuth flow. And that basically is when a user clicks a button inside of the original application. So in this case, we have the Walmart photo app. There's a button that says something like, authorize with Google, log in with Google, access Google Photos, whatever it says, something with Google. Now, when you click that button, that triggers the OAuth process. So that's the first start. So once you click that button to the server, you essentially tell the server, which is here, right? Your browser goes to the server. It tells the server, hey, I want to start the OAuth process. So the server acknowledges that, then it moves on to the next step. Next step is the server sends a redirect notice back to the browser. So it basically tells the browser, okay, I get you want to start OAuth. Here, you need to redirect to Google because Google is the service that your resource sits behind. So you need to redirect to Google and move on to the next step of the OAuth process, which then would just be, your browser here reaching out to the resource server, which is Google Photos. So your browser basically goes straight to the resource server and says, can I view my photos through Walmart? And as you can probably guess, the resource server usually responds back and says, I don't know who you are, bro. You're gonna have to log in. So as we suggest, the resource server says, who are you? Doesn't know who I am. I just requested to see photos. Now that resource server comes with another redirect. So it redirects to login. Login is usually found on the authorization server. So what happens is it tells your browser to now go to the login portion for Google so that you can verify that you are who you say you are. So your browser does just that. So what happens is your browser reaches out to the authorization server and says, can I have a login form? Basically asking the authorization server to be able to log in. In order to log in, it needs something called a login form. So the authorization server responds back and says, sure, here's your login form. And it gives that form. So we'll say F here. So now our browser has a login form. So this is where a user actually just enters their credentials. Could be username, password multi-factor authentication, whatever that looks like. They enter their credentials and they send the form back. So here is where they send the form back in the form of credentials that have already been submitted. So the Google authorization server then is responsible for checking that authorization and verifying that the credentials match with the account that's logging in. And then what happens is the authorization server goes back to the browser and says, what scope do you want to grant? Now, a scope in OAuth is pretty much just a service that limits the application's access to a user's account. So what the login server is basically saying is, what limits do you want to put in place for Walmart while Walmart reaches out to your Google Photos? Now, there are popular scope services that includes, Slack, GitHub, Google, which we're using, right? Fitbit, there are many other services, right? In those services, you can define scopes. And that includes things like read access, write access, selective access, right? Includes things like limited access to a specific view, a wide range of things that you can define in the scope. In this case, we are limiting the scope to, basic user ID, maybe email, and view access, read access to our photos. So our browser then sends back what we call the OpenID based scopes. So that's going to include profile, email, phone, and we'll say maybe picture as well. That's all. So it tells the authorization server the scope, and the authorization server replies back and says, gotcha. Here's an authorization code, right? So it sends some kind of code, which is usually like a combination of numbers and letters. And that code is what you're going to use in order to verify that you have successfully completed the authentication phase in the OAuth process. So you get the code back, and then there's a redirect that comes with that request that redirects you to the application, Walmart. So now your browser sends that authorization code to Walmart that basically verifies and says, hey, I went through the login process with Google and I got this token, or I got this code. It's not a token yet, but I got this authorization code, and you can use this authorization code in order to access the resource that I am granting you permission to access. So Walmart accepts that code and then says, thanks. Now I'm going to send that code to the authorization server. And what the Walmart app is looking for here is what is called a token. This token will then allow the Walmart photo app to access the photos on the resource server. So it sends the authorization code along with some other parameters in the request to the authorization server, and it says, hey, can I have an access token so I can finally access those photos? The authorization server sends a response back saying the authentication code looks good. It verified that the authentication code was good, and so it sends the access token back. Now, at this point, the Walmart app does need to store the token so that it can reuse that token whenever it needs to access resources on the resource server. Now, the token does expire, and if it does expire, there are things that you can implement in OAuth called like refresh tokens in order to basically skip the login process and basically have the Walmart app get issued a new token. We're not going to go into that for this video. Just know that the token is stored. There is a time limit. When that time expires, then you pretty much have to initiate the login process once again so that the Walmart photo app can have a new token that's valid for a set amount of time. Okay, so the token is stored, and now the Walmart application is going to use the token in order to access resources from the resource server. So it says, can I see the photos? I have a token. The resource server then has to verify that that token exists, 1, and 2, that that token is valid. So it verifies that the token is valid. In this case, we'll assume it is valid. And then it sends a response back saying, token looks good to me. Sure. Now you have access to these photos. I've given you authorization. You can access these photos. And then the Walmart application does what it needs to do with these photos. In this case, we'll just say it just needs to view the photos so that it can display it in an application on a screen when the user visits the Walmart app with their web browser. So that is the process of OAuth. It provides authentication and authorization from the browser to a web application that will ultimately need to access a resource server utilizing an authorization server in order to grant that authorization. Lot said, lot to unpack, but when you think about it, all you're doing is delegating the login. So you go to the Walmart app, all it's doing is delegating the login to Google Login. That's it. Google Login verifies who you are and just tells the Walmart app, hey, I verified who this person is. You can access the photos. Here you go. That's it. That's OAuth. Relatively easy. You're just delegating access. Now, people sometimes confuse OAuth with a term called SSO. In fact, SSO is a little different from OAuth because OAuth provides authorization and authentication. In fact, the OAuth 2.0 standard is more used today, but still provides authentication and authorization. Now, SSO also includes something called identification, which is usually done with a third-party plugin or application. I've seen several used. One of the most popular is OpenID. So OpenID is another type of service that verifies the identity of a user. So basically, in this kind of situation, let's say this was an enterprise environment, OpenID would then allow a user to log into multiple applications, assuming the same identity. That's another process. We can cover a video on SSO sometime, maybe in the future. Maybe I'll cover that. But just know for now, OAuth is a part of the SSO process. It is a part, as we said a million times, that answers the authorization and authentication question. It solves the answer to that question. Solves a question by giving an answer, we should say. That's OAuth. Okay, now that we know how OAuth works, let's look into some of the common misconfigurations and ways that we as hackers can probably try to attack this OAuth process, usually in some kind of single sign-on solution. Wasn't so bad, was it? All right, now for the fun stuff. We're going to actually hack OAuth, but as always, the way that we're going to do it is by understanding the different types of vulnerabilities that occur with the OAuth flow and understanding where those vulnerabilities occur throughout the OAuth flow. So first, we're going to talk about the most common misconfigurations with OAuth, starting with improper implementation of implicit grant flow. Now, we went over the use case with the normal, or I would say the most common type of grant flows, which is the authorization code grant flow. That is when a user's browser receives an authorization code from the authorization server and sends it to the client application. And then the client application uses that authorization code to once again send a request over to the authorization server and receives a token. And that token is used for the client application to access the resources that sit behind the resource server. Lots said there, but that's the grant flow that we talked about in our demonstration. Now, implicit grant flow pretty much removes that authorization code process. So what happens is the client application talks to the authorization server and receives a token directly from the authorization server. Now, it is not recommended to use that kind of flow at all. In fact, there's vulnerabilities that arise when receiving a token directly from an authorization server. And we're going to see that. To know for now is that it still happens for some reason, still exists. And not only does it still exist, but there are misconfigurations that exist out there that we'll take a look at. Now, if you must use implicit authorization codes, it's probably better to use that on a static website. That's all. That's what I recommend. The next misconfiguration is authorization code or token leakage. In the OAuth demonstration, we saw how a user's browser interacts with the authorization server to receive an authorization code and then uses that code to send over to the client application so that it can receive a token. Sometimes that authorization code can be sent in the browser. So as a parameter. Now, as you can probably imagine, all an attacker needs to do is get access to that URL that the user is sending data. That can be via sniffing if you're within the same network. If you're not in the same network, that can be using attacks like cross-site request forgery, where the user clicks on a malicious link, and in that link, the user's browser will also have that parameter, that redirect_URI parameter that includes the authorization code or the token, allowing the attacker to receive that authorization code or token. So it's important for the authorization server to validate any authorization codes or tokens so that you can prevent an attack like that. The next type of OAuth configuration is flawed redirect URI validation. So what that basically means is when the web browser reaches out to the client application redirects the web browser to the authorization server, and the user's web browser then starts talking to the authorization server in order to, complete the login form, get the authorization code. We went through this process so many times. I don't have to keep going through this process. But what happens if an attacker were able to manipulate that redirect parameter or that redirect URI? Well, if that were the case, an attacker can pretty much redirect a user, right, to a malicious server and have the user log in to that malicious server. Redirect URI, the attacker would probably have to exploit that with cross-site request forgery, which does require user interaction. But it is still a vulnerability in OAuth, and it is important to make sure that the redirect URI parameter, if used, especially when we're talking in terms of callback, which we can cover callback in more of like an intermediate video on this, then it is important to make sure that that redirect URI is being validated. The next misconfiguration is flawed scope validation. Now, let's say a malicious attacker has access to, an app, a client application, and the attacker had tricked you into visiting that client application and now wants you to log in with OAuth. Well, theoretically, you'll log in with OAuth, you follow that process, the authorization server, will respond back to you saying, I need the scope so I can create this token, limit the privileges, send me the privileges that should be allowed. I'll create a token based off of it, send it to the client app, which is the malicious client app, and then that client app will send an authorization code back to you so that you can send the authorization code to the client app, and the client app can use the authorization code to get a token. You know the process. So with misconfigured scoping, right, if you're not validating that scope, essentially when your web browser sends that scoping limitation to the authorization server, technically the malicious client app can manipulate that scope and just add more values. So let's say your scope was email only. So the malicious client can only access your email. Well, the attacker configured the malicious app correctly. Weird saying he configured it correctly. But if it was configured correctly, you might be able to add to the scope profile, phone, other information, meaning the app no longer has just access to your email, but can also access other things that are outside of the scope that your web browser had chosen. Okay, one of the last misconfigurations I want to talk about today is unverified user registration. So in OAuth, if you're using OAuth for registration, it's important to validate things like email, to validate things like usernames, and identifying information from an existing user, sign up, which would then allow the client app to access a resource as an existing user once the registration is complete. So what do I mean by that? Let's say you have Bob Smith, and Bob Smith's email was bobsmith@example.com. If the OAuth authorization server, right, that handles the registration portion, if that's not validating that bobsmith@example.com exists already, technically an attacker can sign up with another name, but use the same email, bobsmith@example.com, and sign up for this application. So when the attacker goes to log in with that email, they log in as a completely different user who signed up probably through the application itself and not through the OAuth flow, which would be the authorization server in this way. It still happens. It's just a misconfiguration that happens. Absolutely check for these things if you're out there bug hunting or testing. In fact, we might take a look at an example of that. But the way around it is to make sure that the important fields in an OAuth flow for registration are being validated and checked to make sure that there are no duplicate entries. Okay, we've gone through the misconfigurations. Now let's go into exploiting. Let's exploit some of these things. Let's figure out how they work, and let's move on, man. Let's get to the fun stuff. Stay tuned. Okay, now we're at the fun part where we get to actually exploit some of these OAuth vulnerabilities. Now, I want you to think about the thought process behind this while we're going through this, and I'll be trying to go slow, but also walk you through some of the things that you're supposed to be looking for when we're dealing with OAuth types of exploits. So first and foremost, OAuth is an authorization process. So we always want to look at an account section when we're talking about OAuth. So I'm just going to click on my account. Before I do that, I want to open up Burp Suite. Open up Burp Suite, and let's do this. We'll just set proxy settings temporarily because this is an incognito tab and proxy is not added on this. So 8080, and then we'll just also set HTTPS proxy. And this is just to use with Burp Suite. That's all. And Burp Suite is just a proxy interceptor. For those that don't know, pretty much allows me to view the traffic that's going from my browser to a web server and vice versa from web server to my browser. And allows me to also edit that traffic as I'm viewing it as well. It has a lot more features, but for the sake of this lab, that's what we're going to. So now this should work fine with Burp Suite once I start. And what I'm looking for is the proxy tab. That's all. So we're going to pretty much just look at the flow, the auth flow. So let's click on intercept and let's click on my account. Let's see what happens. All right, we don't need this. We don't need this. Okay, this is just a regular GET request. We only look at GET requests if there's some kind of parameter there. Otherwise, we really want just a POST request. Those are the juicy ones when it comes to OAuth. Another GET request. So this one does have parameters. This one has a redirect URI, as we mentioned, and a client ID. So typically, you do want to check and see if the redirect URI will redirect to a valid endpoint. You can just change, the URL here and then leave OAuth-callback. So change this to like malicious.com and see if it'll actually redirect you, because that's where you're going to find a bug there. Another thing you can probably do is try changing the scope. So in profile and email, and you can maybe remove email, or you can maybe add phone, for example. And if the scope changes, then technically you might have like a cross-site request forgery where you would change the scope on a malicious client application. But that would be used in conjunction with the redirect URI there. And then you have your response type. This response type is just sending a token. So remember I mentioned that you can send an authorization code back, and then the web browser sends the authorization code to the client app, and the client app will then use the authorization code to get a token. In this case, there is just the implicit, right? The implicit grant. So in this case, what's happening is a token's being sent directly back. There is no authorization code. So it makes it easier for us. And then you have your nonce there. All right, forward. We don't need that. Let's look at another, see if we can get that post request. So something happened. So it brought me to a sign-in page. Okay, so forward, profile. Okay, so now we need to sign in. Got to sign with the credentials that was given. And let's sign in. And let's click that. So we sign in here. This is where we send the post request to the authorization server. Right? The GET request we don't really care about. There's no parameters. Again, no parameters. We don't really care about that. Okay, so this is where we got the redirect to the authorization server, and well, we're getting the redirect to the authorization server. And so we're going to click continue so that we can be redirected. So continue, post request to confirm. That's just basically saying we want to, follow that redirect. We don't need this. GET request with no parameters. We don't need that. GET request, no parameters. Options, that's just for the API. GET request, I'm just getting my own information. We don't really need that. Post requests, this is for general Mozilla. Okay, so this is the first post request for the OAuth flow. And we're posting to authenticate, and we have the email username and token. Now, for this one, we're assuming that we can reuse a token. There are ways to verify this. You just send this to repeater and see if you can just send the same request multiple times. If so, then you can reuse this token, and you can start playing around with it. In this case, I'm actually going to change the email. So I don't want to log in as Weiner here. I want to log in as carlosmontoya.net. And then my username, I don't want that to be Weiner either. I want it to be Carlos. So we're basically saying we have, we redirected to the authorization server, and now we're going to log in. The authorization server is not validating, validating our credentials, not validating that we are who we say we are. And so theoretically, what's going to happen is it's going to take the username, email, and token, and it's going to accept it. And then it's going to pretty much provide that token back to the client application, so the client application could log in as me. But in this case, it's logging in as Carlos because there was no verification that took place to make sure that I cannot change my email and username. So this is one of the misconfigurations in which, yes, there needs to be some kind of verification, or else a user can't assume privileges of someone else, but also escalate their own privileges when we're talking about things like scope. And that can That'll come later. All right, so let's forward this request and let's see who we can log in as. I'm going to finish intercepting. Actually, we'll follow the flow just to help you understand. Get requests we don't care about. Get requests, and that's it. Yep, so let's intercept off, minimize. We got redirected to the home page. If we click on my account, we see that we logged in as Carlos. So this is an example of the OAuth flow where there is no verification done. Okay, let's move on to another type of lab that you'll see when we're dealing with OAuth. And just know that with these labs, when you're going out there testing, I don't want you to just go and test for these specific type of vulnerabilities. Like, don't test and see if the OAuth server just doesn't verify email or name, because in the real world, there'll be the request will be a lot more complex. There'll be a lot more parameters. The response will have a lot more parameters. What you're trying to do is follow each step of the process. And while you're following the steps, you're just doing little checks. You know, does the redirect URI accept other URLs? We'll jot that down and come back later and spend significant time checking that. Can the authorization code or token be reused? Jot that down. That's something that you want to spend some time looking at. What are the parameters in the login flow or the authorization flow? Write those parameters down as something you want to look at. Can I change the scope? Write that down, something you want to look at. If the access token or the access mode is set to token, see if you can change it to auth code. Or if it's set to auth code, see if you can change the token and kind of have that implicit grant kind of flow there. So what you want to do is, as you're going through these steps, write down the parameters and write down the push requests you see. Those are the things you want to focus on while you're working on these OAuth based bugs and trying to find issues with that. You did it. You learned OAuth. Look what you did there. Now, it's important to note, I did not go into any advanced hacking simulations, labs, or explanations, because there's still more information that you need to know about OAuth before you start understanding some of the attacks. Exploits on OAuth can be very complex, so we'll save that for part 2. And yes, there will be a part 3 for even the most advanced attacks. But first, we got to learn how to walk. So stay tuned for part 2, where we go one level deeper in the OAuth process, and then we start looking at several exploits that occur: cross-site request forgery, things like open redirect, things like account takeover, a bunch of things that we can go over. If you enjoy these videos or you have any requests, feel free to leave a comment below and let me know what you like, what kind of video you'd like to request. And yes, I do check those comments. I've seen things like reverse engineering, AI, GraphQL part 3. Those are all in the works. Don't worry, I have something special for you guys. Like I always say, I got you. I got you. Lastly, if you want to stay tuned, absolutely go ahead and hit that subscribe button. Like this video, comment just because. Why not? Why not? And that notification bell thingy, yeah, go on ahead and turn that on. Go ahead and turn that on. Appreciate you guys. Tap out.